Yes, hello everyone. Welcome to Coding with Zaharah Bidin. Today I'm going to talk about a mask detection model. And a mask detection model, this system or the model checks whether a person is wearing a mask or not. And I came up with this due to the high levels of contracting COVID-19 generally in the whole world, and particularly in my country. We are also facing another upcoming disease, which is called Ebola. And I feel like this idea would work better for the public places that cannot regulate all the majority of the people who visit them to put on masks. And through creating this system, I think it would work better to also control or reduce the number of labor employed to ensure that people are observing the SOPs, that is the standard operating procedures. The problem to be solved, um, the problem to be solved is ensuring that the people are observing the standard operating procedures that the SOPs that should be followed to prevent the spread of COVID-19 and also Ebola as well, because those are deadly diseases, like we all know. And it also helps the community to reduce on the high levels of contracting these diseases, and also reducing on the expenditures, the treatments, and the death rates as well. How artificial intelligence has been applied. Um, this system works with existing surveillance systems, that are CCTV cameras, um, whereby we shall use the CNNs, that is a convolutional neural networks that is capable to train the data set of both persons wearing masks and those who are not wearing masks. And after, it can detect whether a person has put a mask on or not. The type of data to be used, or the face mask recognition model, which is based on the CNN model, is the dataset that consists of facial images of the people with and without masks. The difference between supervised learning and unsupervised learning. When you talk about supervised learning, it's a machine learning approach that is defined by its use of labeled datasets. In this, I can give an example of a doctor or different types of doctors who give out the same different types of medicine to treat different diseases, and the some people survive and others do not survive. And we can use the data of the people who have survived and those who have not survived to help our machines learn. Like, in case for the people, we take out the people who have survived, and the machine can learn from that medicine that is used to help those people survive. And unsupervised learning uses machine learning algorithms to analyze and cluster unlabeled datasets, and therefore it does not need any human invasion. In this, we don't need, in case, let me give this make example. In case those doctors talk about the medicines died, if they died, so we shall not have people to consult from, so we shall just do it probably like with probability, check the people who survived and those who didn't survive. We check what medicine was given to those who survived and what medicine was given to those who didn't survive. And in that, we are undertaking a risk through probability, and that is unsupervised learning in the short term. And supervised learning techniques that are to be used in this, we should look at the neural networks like the convolutional neural networks, the CNNs, and I've already talked about that architecture, whereby the CNN architecture is used to, it's trained to distinguish people with and without masks. And deep learning technique is used in situations such as image classifications or object detection. So it will have to classify those people who are putting on masks and those who are not putting on masks. And it's used to label all number, the input and the output, both are known. And as the levels of those images are known, the network is used to reduce the error rate. So it's a supervised learning technique. Unsupervised learning technique, we shall have to look at clustering. This involves grouping of facial images according to the face identities We shall have to look at the people who are putting on masks and those who are not putting on masks. So it will have to identify and cluster them and show the machine that these are the people putting on masks and these are the people who are not putting on masks. The social network analysis is also another unsupervised learning technique that is to be used. And this is the facial recognition can be used to tag people's faces in photos across social media platforms and face detection forms of foundations of this application. And furthermore, the data can be used for the machines to learn. So we shall have to go on different social media platforms like Instagram, Facebook, WhatsApp, Twitter. Check out the people who are putting on masks and those who are not putting on masks. And that the data collected can be used for the machine to learn. The challenges that I'm likely to face, occlusion is considered one of the most critical challenges in the face recognition. And this occurs with the people having beards, mustaches, and accessories, masks, nose pins, nose rings. And this is a preventive in the real world scenario. So it can also be a problem. Then low resolution, whereby you look at places like hospitals, ATM cameras, supermarket security cameras. Those cameras are usually put a distance away from the people. So they have low resolution. By the time you match the image, like you cannot easily identify that particular person or that particular face, and therefore the face itself cannot be properly captured to differentiate between the different type of persons. And this can also be difficult for us to identify that person who's not putting on a mask, because literally we are targeting those who are not putting on masks, that are not observing the SOPs. So low resolution can be a problem or a challenge in this manner. The facial variations, like you see on the example, one is smiling, one is sad, silent. So the different facial variations of the same individual are a significant factor that needs to also be taken into account. And this can be a challenge in this manner also. So the possible solutions to the problems could be locating visible facial segments, and this can be a problem to occlusion. So this can be done to estimate if the visible parts of the face are known. The person is having a mustache, you can know the nose, the eyes, due to occlusions that are largely revealed. So the other solution could be by using the 3D assisted face recognition, which can be done by using sensors to capture the shape of the face with or more precision. And this can be a solution to the face variations. So the 3D assisted face recognition can be done by using sensors to capture the shape of the face with more precision. So even if you change the smile, even if it becomes that you'll be the same person, and the machine can easily identify you. The low resolution can be solved by the use of the super resolution. Yeah, so that the faces can easily be captured despite the length or the distance between the faces and the cameras. But the use of the super resolution, the problem can be solved since the faces can easily be located. Even when it's merged, the person can easily be identified. This is this and this is this, and therefore the people who are not putting on masks can easily be identified. Now, the differences between accurate recall, precision, and F1 score. Firstly, precision, recall, and accurate are three metrics that are used to mean performance of machine learning algorithm. F1 is an evolution metric for classification defined as harmonic mean, precision, and recall. In other words, it's categorizing the two things. Then precision is a ratio of correctly classified positive samples, that are the true positives, to the total number of classified positive samples, either correctly or incorrectly. Then that brings the difference between precision and recall, whereby recall is also a ratio of positive samples that we properly categorize as positive to the total number of positive samples. In this, we're not looking at either correctly or incorrectly. Then accurate is a proportion of correct predictions in all predictions made. In other words, we categorize all the predictions made, and those ones that are correct will be regarded to as accurate. And the appropriate AI metrics, evaluation metrics that are to be used. I would look at the convolutional neural network. Is a kind of network architecture for the deep learning algorithms and is used to specify for if image recognition, and the task involves processing of the physical data. Remember, physical data. So remember, we are dealing with a picture images, so we should always look at the pixels rather. Yeah. Then the support vector machine, the SVM, is a type of deep learning. It's also a type of deep learning algorithm that performs supervised learning for the classification or regression of the data types. So it will have to classify that, like in this manner, the people who are putting on masks and those who are not putting on masks. The references are those, the summary on face detection researches and the real-time face tracking method of color images, study of coding algorithm with wavelet based on color face images, and also that link that is for the world, for the coronavirus, that like I read about it, so it was also necessary. So thank you for listening. Please, after watching this video, subscribe, like, and share. Wish you the best.